to cross-brain engineering arena. My name is Osei, Kofi. You can call me Engineer 1. Today, we are going to practice about how to construct a cycloid. A cycloid is a curve generated by a rolling circle on a fixed straight line. So, this is a TLM, it's a circular object. So when this circular object is placed on a horizontal surface and rolled along the horizontal surface without slipping, it has to go straight. It will generate a curve at the end of one revolution. So that curve that will be generated by this circular object is what we call a cycloid. Why do we have to learn about a cycloid? We have to learn about a cycloid because it plays an important role in construction. Cycloidal shapes plays important role. Cycloidal shapes are like curves. And sometimes in construction of road, we need a curve to avoid an obstacle. So, in that area, in the construction of road, we need a cycloid. And in construction of a building, sometimes we need to achieve a certain circular shape. There is one structural element called an arch. We have different kinds of arch. I'm talking about the circular arch. So you can see that most of us who have had the opportunity to see a circular arch, that circular shape is similar to what we call a cycloid. So at this time, we are going to practice about how to construct a cycloid. Alright, this is the data required to construct a cycloid. Basically, you need the diameter of the rolling circle, and it is given by 50 millimeters. You need the length of the rolling circle, which is given by pi d. The d represents the diameter of the rolling circle. And then pi, you multiply pi by the diameter. So 3.142, which is the pi, times 50, which is the diameter of the rolling circle, and we're going to have 157 millimeters. So 157 millimeters is the length of the rolling circle. Basically, this is what you need to be able to construct a cycloid. So let's start. First of all, you have to draw your rolling circle. The diameter is 50. But you have to use the radius of the diameter. The radius is half of the diameter. You measure it. In this case, the radius is 25 millimeters. So 25, this is 10, 20, 25 millimeters. So you first of all strike your circle. Right, that's the circle. Then we have to divide this circle into 12 number of equal parts. To be able to do that, you have to first of all divide it into 4 number of equal parts. And let's begin with drawing a horizontal line to run through the center of this rolling circle. That is done. We have to then shift our t-square down and place any of the set squares on the t-square and draw a vertical line to run through the center, and that will divide the circle into 4. We are not interested in 4, we are interested in 12. So we then take measurement, which is the radius of the rolling circle. We strike an arc over here. We strike an arc over there. We move to the other point here. Then we strike an arc here. We strike an arc there. You keep on repeating the process until you exhaust all the 4 points. Okay, now the circle has been divided into 12 number of equal parts. We have to number it. Then let's start. This is 1, this is 2, this point is 3, this is 4, this is 5, this point is 6, this point is 7, this point is 8, this point is 9, this point is 10, this point is 11, and finally we have 12. Alright, then we have to draw series of lines to run through the center from the points. So let's start from point number 1. We have to draw a line to run through the center to hit point number 7. Then we have to move to 2. We draw a straight line to run through the center of the rolling circle to hit point number 8. We move to 4. We do the same. Then we move to point number 5. Right, so we have divided our circle into 12 number of equal parts. The next step is to draw the length of the rolling circle. This is the rolling circle. We need a length. We have to draw it. We have to draw it from point number 12. So let's first of all draw any straight line from 12. Okay. This line measures 157 millimeters. So you just take the measurement with the aid of any of the set squares. I think this one seems to be a bit appropriate for me. So from point number 12, we mark off 150, 155, 156, 157 millimeters. You mark it off. So then you draw a vertical line from the point that you have marked off. Make sure that line is perpendicular to this line drawn. So just draw any vertical line. Okay. So the next step again is to draw a series of straight lines from the points to hit this vertical line. So 1 and 11 are corresponding. So draw a straight line. This is 11, this is 1. 11 will run through 1 up to this point. Then you move to 10 and 2 are also corresponding to each other. So you draw a straight line to run through 9 and 3. You just have to extend 9 and 3. Right? Then we move to 4 and 8. And you move to 5 and 7. Then finally you have 6. All right. Okay, at this point, just as we have divided our rolling circle into 12 number of equal parts, similarly we have to divide the length of the rolling circle into 12 number of equal parts. So let's use this technique. Just draw any straight line at any angle from point number 12. And divide this line into 12 number of equal parts. Okay, let me extend it a bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and finally 12. Right. So you join the last point. All right. Then, with the aid of your set square, you manipulate it. Manipulation of set squares. Then you try to place one of your set squares along the line drawn recently. So you shift it down This is point number 11, right? You draw a straight line, shift again, you keep on repeating the same process until all the points are exhausted. Right, so we have divided the length of the rolling circle into 12 number of equal parts. Right, so now we have this point. We have this point, right? This is point number 1. Okay, point number 2, point number 3, point number 4, 5, 6, 7, 8, 9, 10, 11, and finally 12. Alright, so we have to then draw perpendicular lines or vertical lines from the various points. Draw straight line, vertical line. You move to point number 2. You draw another straight line. You continue to repeat the same process till you exhaust all the points. Right. We have divided the length of the rolling circle into 12 number of equal parts, just as we did to the circle. Alright, so at this point, this is the center of the rolling circle. Okay, this line is very, very important. This particular line that runs through the center of the rolling circle is very, very important. And so let me try to deepen it a bit. All right, so you start at the various points. You have to label it. Okay, so you can call here C1 C1 means center 1, right? And here is center 2. This point is center 3. This point is center 4, center 5, center 6, center 7, center 8, center 9, center 10. Center 10. Center 11, and finally center 12. Alright, so we are now going to locate points where the cycloid will pass. So we have to take our radius of the rolling circle, right? Then we strike an arc to cut across the horizontal line 1 and 11. You move to center 3, you locate the horizontal line 3 and 9 and strike an arc. You move to center 4, you strike an arc to cut across horizontal line 4 and 8. You move to center 5, you do the same thing. You strike an arc to cut across horizontal line 5 and 7. As for 6, it will not cut across, it will hit the apex, right? You continue to repeat the same process till you exhaust all the points. Alright, then at this point, you have to use your free hand to draw a smooth curve to pass through the points, and that will give you a cycloid. Alright, this is where we bring to you the end of today's lesson. If you have any suggestions to put across, you can look for Coarse Brain Engineering Arena on YouTube. If you think this video has added a value to your studies, you can like and share to others for others to learn. You can subscribe to the channel that is Coarse Brain Engineering Arena for more tutorials. Thanks a lot. God bless all of us. See you another time.